Hello students. Today I'm going to continue scale diagrams. I hope all of you have watched the first video about the scale diagrams. In that video, I have told you from that video, I have taught you all the theories to do exercise 27.1 and exercise 27.2. Right? So from the video itself that day I have discussed in exercise 27.1 question number 1, 2 and 3, and I have appointed you to do fourth question of exercise 27.1 for the homework. So I hope all of you have done that. Now I'm going to discuss that question. Exercise 27.1, question number 4. Right, let's move to this. From a number 1 of that question says, ABC is an equilateral triangle. B is situated to the north of A. Right, now equilateral triangle ABC, B is situated north of A. So definitely B is situated north of A. So this is no north, right? So definitely the line AB is a straight line and you are getting the triangle like this way. And this is not a right angle triangle. Okay, children, you don't misunderstand that this is like a right angle triangle. Right, just the line AB is a straight line because they are telling B is situated to the north of A. That's only. Then you are getting this kind of a triangle and this is equilateral. This is Roman number 1. B is situated north of A. So here it is C and this is equilateral. As this is equilateral triangle, right, these interior angles are 60 degrees each. Like this, you can illustrate the triangle. Right, always in equilateral triangle, each interior angle is 60 degrees. Then, by considering the sketch, determine the following. So, you're asking some questions regarding the sketch, right? We'll see. A, bearing of B from A. From A, no? So, bearing of B from A. Right? So, it is straight away along the north direction, no? So no angular value. It is a straight line. Then, we have to say there it is 0 degrees Celsius. 0 degrees, not Celsius. It is just 0 degrees. Right. Then B part, bearing of C from A. Bearing of C from A. Right. When consider C from A, this is the angle. No? So that is just 60 degrees. So for B part, that is 60. So you have to write it as 0, 60 and degrees. Then C part, bearing of C from B. So from B means for B, no, you want to get north. From B, this is the angle. So here 60 means it might be 120 degrees. So answer for C part is 120 degrees. D, bearing of B from C. From C, no? Then here north. Bearing of B from C. Now we want this angle, no? How much is here? Now we know as this is 120, here might be 60 mean. So this value is 360 minus 60. So that is 360 degrees. For D part, you are getting the answer 360 minus 60 equals 300 degrees. Then E part, bearing of A from C. I'll do it with blue color. Bearing of A from C. So bearing of A from C mean up to here, no? Right? What I mark with blue. Then this 60, 60, 120, no? Then you can have the answer from 360. You can subtract 120. Then answer is 240 degrees. Answer is 240 degrees. Then F. I'll do it with black. The bearing of A from B. Now, bearing of A from B. So, from B, A is sharp downwards, no? So, that is 180 degrees. Answer for F part is 180 degrees. I hope all of you have got correct your answers for these A to F. That's all regarding this. And in exercise 27.2, I appointed for the homework question number 2 and 3. And I wanted to do a small correction in the first question, Roman number 2 also. First question, Roman number 2, that day I told like another answer. For Roman number 2, answer is 228 degrees. I told 24 or 22 like that. So please correct it. Right? Answer for first question, Roman number 2 is 228 degrees. Right? That is about exercise 27.2. Right. Now let's move to discuss question number 2 of exercise 27.2. Hope all of you have completed that. Roman number 1. Right. Now look at, you are given a figure. PQR denote 3 harbors located in the same ocean. Q is to the east of P. Q is to the east of P. Describe the route in terms of the bearing and distance that a ship needs to take to a journey. Right. So I'll have a small sketch regarding that figure. You are given this way and again this way. Here P, Q, R. Right? This distance is, children, 150 kilometers and QR distance is 200 kilometers. Don't misunderstand that it is like PR. Okay, that's why I have shown it in the figure. And this angle is 54. These are given. Right? Straight away, Q is to the east of P. You can see, no, Q is to the east of P, like our previous question. B is north of A, like that. Here, Q is to the northeast of P. Right. Now, describe the route in terms of the bearing and distance that a ship needs to take to journey. Children, when I'm reading the questions like this way, please, you all refer your textbook. Don't just listen to this video and wait. Refer your textbook also, then only you may further understand, because always I'm reading the question from the textbook and only explaining these questions. Right. Now, Roman number 1, from harbor P to harbor R through Q. Now, you want to explain this. Right. Now, how to explain? Right. With the bearing. So, when they are asking us to say with the bearing, straight away we can't tell Q is to the east of P, like that we can't say, right? So from P, if we get an angle, this is 90. No? So according to that only we want to say. So how can we say harbor? We can say harbor Q is 150 kilometers away from P on a bearing of 90 degrees, and harbor R is 200 kilometers away from harbor Q on a bearing of 180 degrees. Like this, you can say the answer for Roman number 1. And don't forget to write the degree sign. This is Roman number 1. Right. Now let's see what is asking by Roman number 2. Directly from harbor P to harbor R. Directly from harbor P to harbor R. Now direct distance we want. So first of all, you want to find the distance of PR by applying Pythagoras theorem. Then how to find PR squared equals PQ squared plus QR? No. So PQ is 150 squared plus 200 squared. So by the Pythagoras theorem, you get this answer. You are getting 150 as 22,500. 200 squared as 440,000. Then sum of this is 62,500. Then to get PR, you want to get the square root of this. Then your answer will be 250 kilometers. So by the Pythagoras theorem, first of all, you want to get the distance of PR, that is 250 kilometers. Right, now we know the distance. Then how to calculate the angle? 90 plus 54. Right, now R is 250 kilometers away from P on a bearing of 144. How 144 coming? 90 plus 54. Right, because considering P, no, from P to harbor R, no asking. So considering P towards the north direction clockwise, we want to consider the angle. Then we can have the answer in this way. Harbor R is located 250 kilometers away from P on a or with a bearing of, on a bearing of 144 degrees. How 144 comes? 90 plus 54. Right, this is how you are getting the answer for Roman number 2 of the second question. Hope all of you understood this. Right, now let's move to the third question of exercise 27.2. Right, in the third question, you have to get the sketch. A pilot of a certain airplane which is scheduled to fly from Colombo to a certain airport has been instructed to fly 100 kilometers on a bearing of 20 degrees and then another 100 kilometers on a bearing of 80 degrees. Represent this information in a rough sketch. That is your Roman number 1. Right. Now from Colombo, so respect to Colombo, you can get the direction of north. Right here it's Colombo. Right, it goes 20 degrees, right? Within 20 degrees, no, so 20 degrees mean a small angular valley. So it is like this way. Very small angular valley. Right, 20, no, just this angle is 20, here 100 kilometers. Then from that, right, another from that place itself, then another 100 kilometer on a bearing of 80. Now for this position, you have to get north. For this position, you have to get north, right, and 80 degrees. Then how to get 80 degrees? For this, as I have started it at the top of the page, it's a bit difficult, but I'll do it. Hope you all clear. Right now from that position, it goes another 100 kilometers with the bearing of 80 degrees. Right? And goes to the final position. They won't tell that as A, B or something. That's why it is easy for us if we mark this is as A and this is as B. It is easy for us our further solutions. Right. Now this is the figure. No matter, you can mark like this A and B. If not, how can we denote this point and this point? That's why for our easier, to make the question easy, I have marked these points as A and B. Right. This is the rough sketch. Now let's see what is asking by Roman number 2. Write a description of the route that the pilot needs to take if he's to fly back to Colombo from the airport along the same path. Now he is coming back. Right. Now when he is coming back this way, no, he is coming. What I mark in blue color. Right. Now we want to say the path. Right. Starting from B. Now respect to B, we want to mark north and we have to measure what is this angle. Now how to get this angle? As this is 80, here might be 100, no. Then 360 minus 100, here is 260. Now from the final place or from B, it comes to A, 100 kilometers on a bearing of 260. Then from A to Colombo should come. Now we want to find how much is this angle. Right. Now as this is 20 degrees, right, there are so many ways of getting this. Once you consider this downwards, right, this is also 20, no? Alternate angles. Then this is a straight line, no? Up to here it's 180. Then 180 plus 20, that is 200. Then from A to Colombo with the bearing of 200 degrees. Now you have to explain it in words. Then we'll explain it in this way. Fly back 100 kilometers from B. From B mean final position. Right? Previous journey's final position we consider as B. From B to A on a bearing of what is the bearing there? 260 degrees. And then to Colombo Airport from A on a bearing of 200 degrees. I hope this is clear to you all children. Don't forget to mark the degree sign. Right, that's all about exercise 27.1 and 27.2. I hope all of you have understood this very well. Right, now let's move to the third part of this lesson, scale diagrams in a horizontal plane. Scale diagrams in a horizontal plane, page number 86. Right. We'll consider the example given in your textbook itself on page number 86. The vertices of a triangular flow area A, B, and C, the positions of the vertices with respect to a point P located in this area is given below with respect to P. Right, you are given the location. See the next page, 87. A is located 30 meters away on a bearing of 100. Right, so now considering the location P, you know, these things are there. So this is the location P. So corresponding P, you have to mark north. Right, this is the direction of north. Then A is located 30 meters away on a bearing of 0. So definitely A is along this arrow mark north. So here A, here the distance is 30 meters. Always bearing of 0 means along the direction of north. Then B is located 40 meters away on a bearing of 120. So 120 is such a distance, no? Right? Length is 50 meters. And this is the position of B. Then C is located 45 meters away on a bearing of 220. So always respect to north, 220. Now, up to here, 120, no? Right? This angle is 120 degrees. Now, 220 mean another 100, no? Right? You can keep the protractor and draw these children. So, another 100 degrees coming means it's like such a. You just keep your protractor and get. Then, here to here, it might be 220 degrees. This is the position of C. If you ask only this value, that is 100. Right, now this is the sketch. Right, draw a scale diagram of the flow area using this information and find its perimeter. Right, now you want to find the perimeter of this figure. Right, now first of all, now our lesson is scale diagram. So from the question, this is the rough sketch you obtain. Right, we'll consider this as our rough sketch because 30 meter, 50 meter, and this distance is 45 meter. We can't get these exact values, no? Right, now this is our rough sketch. Now we are going to draw the scale diagram for this, and let's find the perimeter of the figure. Right, now you are getting a perimeter, no? So once we are finding the perimeter, these AB, BC, AC, some of these we want to get. Okay, this is our rough sketch. Now we want to consider a scale. See the question, have they given a scale for us? They just say draw a scale diagram of the flow area using this information and find its perimeter. Right. Now, they were not given a scale for us, but in the step 3, they are telling take 1 to 1000. Right. Now, let's draw the scale diagram. They have given the scale as 1 to 1000. Right. That means 1 to 1000 scale means from 1 centimeter, they show 1000 centimeters. 1000 centimeters mean 10 meters. Right? Therefore, now we know to show our 30-meter distance, we have to get 1 centimeter, 10 meter, no? Then 3 centimeter. And for our 40 meter, right, don't write equal. For 40 meter, we have to get 4 centimeter. And for 45 meter, we want to get 4.5 centimeter. Right, now we understood. Now how can we get the length? Or instead of this, you can write P. Right, 3 centimeters mean distance of PA. And this is PB. And this is PC. Right, now you got the scales and everything. Right, now according to the scale, you have to draw the structure. Right, so you can, first of all, you can draw 3 centimeter length. This is P, this is A. Now as this is our scale diagram, we show the length in centimeters, then keep the protractor and take 120 degrees. Right, you have to keep the protractor in this way. Okay, like this way keeping. Then measure 120. Right, then the length of this line must be 4 centimeter. And this is the position of B. And then again, once you keep the protractor, you can keep the protractor along this way. If you take, then you can take 100 here. Then altogether it will be 220. That is the position of C. Length of that line is 4.5 centimeters. Okay. After that, with dotted lines, you match AB, BC, and AC. Right, you can measure the lengths of AB, BC, and AC. Right, they are not given. According to your figure, you want to get the measurement. Right, nearly you check whether are you getting these lengths. Nearly the length of AB might be 6 centimeter. Sometimes you may get either 5.9, 6.1, 1 decimal point up and down, error, no matter. And you may get the distance BC like 6.5 centimeter. Right? And AC distance you may get like nearly 7.1, either 7 or 7.2 even, no matter. Right? Then to find the perimeter, this is a flow area. No? So perimeter of the flow equals, now we have to consider the actual distances. Okay, 7.1 centimeter mean from 1 centimeter we denote 10 meters. No, so 7.1 mean 71 meter. 6 centimeters means 60 meters. 6.5 centimeters means 6.5 meters. Then sum of this is 196 meters. The total perimeter of the flow. This way also you can take. If not, you can just add 7.1, 6 and 6.5. Then you are getting 19.6 centimeters. So once you convert straight away 19.6 centimeters into meters, it is 196 meters. By that way also, you can get the answer. Hope all of you clear about example 1 of the, right? This is example 1 under the heading 27.3 scale diagrams in a horizontal plane. Right. Now let's move to the second example. We'll do another example, which is on page number 88. Right. Okay, children. Let's see example 2, page number 88. A ship journeying from Harbour P approaches Harbour Q after traveling 100 kilometers on a bearing of 48. It then travels 125 kilometers on a bearing of 110 and approaches Harbour R. Draw a scale diagram and describe the position of R with respect to P. Right? So normally, once you're asked to draw scale diagram, straight away don't go to draw the scale diagram. First, you have to have a rough sketch. After the rough sketch only, you are going to draw the scale diagram. And always, once you draw the scale diagram, under the scale diagram, you want to mention the scale. It is compulsory under the scale diagram. Or see the previous example. Right here, I have shown like this way. You have to mention the scale what you have drawn. It is a must. Right. Now let's do example 2. First of all, we'll get the rough sketch. Once you get such questions for the exams also, not in the rough paper, in your proper paper itself, get the rough sketch. When we get the rough sketch, we won't measure exact values. We just mentally refer the values and only put. Right, now let's see. A ship journeying from Harbour P approaches Harbour Q after traveling 100 kilometers on a bearing of 48. Right, now let's consider this is Harbour P and 48 degrees means such a value, and it goes 100 kilometers to Harbour Q, and this is 48. Right, no need to keep the protractor and measure, just do, because then you can have an idea about how to draw the scale diagram. It then travels 125 kilometers on a bearing of 110. Now at Q, you want to keep the direction of north. 120 degrees mean 110. So like this way, this position is R and this distance is 125 kilometers, right? Now this is your rough sketch. Okay, now let's move to draw the scale diagram. If they haven't given you a proper scale, you consider the distances 100 kilometer, 125 kilometer. Now from 1 centimeter, if you go to show 10 meters, from 1 centimeter, if you go to show 10 meters like that, we can't do this. No. So earlier question, we had the length in meters, right? Earlier rough sketch, you remember, no? We had the length in meters, 30 meter, 50 meter, 45 meter, right? Meters. Now we have kilometers, no? So if we show 10 kilometers by 1 centimeter, also we need nearly 10 centimeter, 12.5 centimeter. So it's difficult to draw 10 centimeter, 12.5 centimeter even in your exercise book, no? Right, so you have to be mindful about selecting the distances also, right? So 1 centimeter, from 1 centimeter representing 10 kilometers is not okay for this. Right, now how do we decide the scale? Right, shall we show from 1 centimeter? You just assume from 1 centimeter we go to show 50 kilometer, then for 100 just 2 centimeter. So very small value, no? Understand? So that's why shall we take 1 centimeter represents 25 kilometer. That's a better scale. 1 centimeter represents 25 kilometer. If we get like that way to show the distance of PQ PQ distance is given 100 kilometers. No? So 25 by 1 centimeter means we have to draw length of 4 centimeter for PQ. Then QR is 125 kilometers. No, so to represent that we have to have a length of 5 centimeter. Right, now we are okay with the distances also. Right, now let's draw the scale diagram. Right, then now let's get the scale. Scale is 1 to 25 kilometers. No, 25 kilometers mean meters 25,000. And again, we have to show another centimeters wise. So we are taking this, right? Then 2,500,000. So our ratio is 1:2,500,000. Hope all of you clear. How did I get this? Right, again I'm showing, please see. 25 kilometers, right? 25 kilometers we multiply by 1,000, then we are getting 25,000 meters. Then again we have to multiply this by 100 to convert this into centimeters. Then 00 added. So this is 25,000 centimeters. So in other words, by leaving the space, I can take 2,500,000 centimeters. That's what I have taken here. Hope all of you understood. Right? You have to know these unit conversions. It is a must. Right. Now, okay. Right. This is some extra part I have just shown you. So it's enough of writing the scale. 1:2,500,000. Okay. So this is our scale. According to the scale, now you can draw the scale diagram. First, you mark the position of P respect to that north. Then keep the protractor this way. Right, this way you want to keep the protractor and measure properly 48 degrees. And I just erased this. I just shown you that to show you now our distance PQ is 4 centimeter. So take 4 centimeter, only up to 4 centimeter you are drawing. So this is the position of Q. Then from Q, have a north. Then again, keep the protractor this way and measure 110. Then you are getting the distance in this way. The length of that is 5 centimeter. And this is the position of R. This angular value is 110. Now, this is your scale diagram. After that, you can match PR. In our question asking, draw the scale diagram and describe the position of R with respect to P. Now, in our question asking position of R with respect to P. Right, so again from P we want this north direction. Now we want this angle and also this length. Right, now you can just keep the rule and measure this length. Right, so this is nearly you are getting either 7.5 or 6 or 7 like that. Right, this distance is 7.7 centimeters. Right, in centimeters. Now, how do we find this angle? Right, this is 48. No, we know that this is 48, only up to here. Then how to find this angle? You want to think a way of finding this. How can we find this angle? Think a method how to find this angle. Right. Now we'll just see, I'll mark with the color of green. Now our problem is how to find this angle. If we know this angle plus 48, we can have the value of this. Then how to find this is the case. No? Right. What is the way of getting this value? Okay, did you find how to get this value? Right, now you know that this is a scale diagram. As this is a scale diagram, you can just keep the protractor in this way and can find the angular value up to here. Right, that way also okay, because of this is a scale diagram. So that value will be getting 82 degrees. Then you're asking, describe the position of R with respect to P. Then you can write R is situated. Now this distance 7.7 centimeters. No, right? Then how to take 7.7 centimeters? How do you get the actual distance of this? Right, 7.7 you want to multiply by 25, because from 1 centimeter you have shown 25 kilometers. No, then 7.7 you multiply by 25, then 192.5 kilometers. Therefore 192.5. Right, therefore R is situated 192.5 kilometers from P. We'll write P in capital on a bearing of 82, 82. Right, that's all about the example 1 and 2. Okay, children, now by referring this video very well, refer thoroughly how I have explained here example 1 and 2, and with this knowledge, please complete exercise 27.3. And I will bring the solutions of exercise 27.3 also from another video. And all of you remember, I have done these lessons in this way because of the present situation of the country. Right, due to power cut, sometimes when I have power, you may not have. So likewise, we are getting so many clashes. That's why all of you can't join for the lesson at once because of this timely problem. So we have another one lesson only to complete in this way, data representation and interpretation. That lesson also via a video like this way I'm sending, and you are feel free to ask any question, errors, what you get along WhatsApp messages. Don't worry, anything you can ask. If you can't type, leave voice cards, or if you want, you can give me a call, no matter. You are feel free to ask any doubts, any errors, what you get throughout these videos. And if you have any difficult or doubts, let me know the time duration of the video, then I will explain it further for the students who are having questions. Okay, then do and keep exercise 27.3. God bless your children.